Let's jump right in. Building digital spaces out of thin air is just absolutely fascinating. In today's explainer, we are diving deep into the foundational logic of Python game development. We're going to look at exactly how an entire interactive universe gets architected, literally from absolute scratch.
It all kicks off with this fundamental question from our source text. How do you actually build your own game using Python? Well, to really answer that, we need to totally shift our mindset. We have to stop thinking like players for a minute and start thinking like digital architects staring down a completely blank canvas.
Okay, let's dive into this. Take a look at this fully realized, super vibrant pixel art world. As players, right, we just see these cool floating islands, the inviting blue water. It's a place we want to explore. But to actually build this in Python, we have to understand how to systematically construct every single piece of it piece by piece.
Section 1. Architecting Digital Worlds.
So if we systematically peel back the layers of that scene we just looked at, we start to see all the distinct visual components we need to actually program into existence. It's kind of like a giant puzzle. First up, the background. You've got that solid blue sky and those fluffy white clouds. Then comes the static terrain, meaning the dirt and grass blocks that make up the physical foundation. Next, we throw in the interactive elements, like those wooden ladders. We've also got to account for environmental hazards or boundaries. Think the deep blue water bubbling at the bottom. And finally, the icing on the cake, the decorations. Red mushrooms, trees, bright flowers. And here's the kicker. Every single one of these categories requires a very specific set of instructions in Python.
Moving on to Section 2, Deconstructing the Canvas.
Now, what's really interesting about this is that behind all those organic, fun shapes lies something entirely different. I want you to imagine an invisible, highly precise X and Y coordinate grid just totally overlaying this entire environment. Every single block of dirt, every tiny mushroom, the exact starting point of that wooden ladder, they are all pinned to a specific exact coordinate on that hidden grid.
This sets up such a stark contrast. On one side, you have the player's view, right? A fun, explorable world packed with wonder and tricky platforming challenges. But on the flip side, you have the Python architect's view. To the person coding it, this beautiful, lush world is literally just a precise X and Y coordinate plane. It's a matrix of raw data, dictating exactly where graphics are drawn and where collision detection happens. Honestly, the real magic of game development is making all that rigid math feel like a seamless adventure.
Which brings us to Section 3. Grids, Tiles, and Python. If you're getting into 2D game development, the absolutely most fundamental concept you need to grasp is the tile. Basically, a tile is a repeating square graphic block that we use to efficiently construct a game environment right onto that grid. If you think back to our scene, notice how the terrain breaks down into those blocky square pieces. Instead of drawing one massive, complex, custom floating island, Python just stamps out these individual tiles, brown dirt squares, green grass squares, over and over again across the grid. It's super efficient.
So, with these tiles in our toolkit, we can actually walk through the step-by-step logic required to assemble the static parts of our world. Step 1, we have to define the window resolution in Python. Step 2, we map out that hidden coordinate grid we talked about. Step 3, we literally loop through that grid to place the terrain tiles, snapping those dirt and grass blocks right into position. And finally, Step 4, layering on the fun stuff, the decorations. We pop the red mushrooms and the flowers right onto specific coordinates sitting on top of the grass.
Let's step it up in Section 4, Coding Platformer Physics.
And this brilliantly illustrates why physics matters so much. Without physics logic, if a character stepped off that top floating island, they would just fall indefinitely, right off the screen. The Python code has to constantly calculate gravity, actively pulling the player down on the y-axis until, boom, it detects a collision with a grass tile, immediately stopping the fall. Similarly, the code has to recognize the specific grid coordinates of, say, that wooden ladder, which triggers an entirely different logic that bypasses gravity and lets the player climb up and down.
And that brings us to another really critical concept in all this, the sprite. While tiles make up the static, unmoving world, a sprite is an independent, interactive 2D image or animation that actually moves within that world. Picture a player character jumping over the water, or maybe an enemy pacing back and forth on an island. Those are sprites. They have their own dynamic X and Y coordinates that are constantly updating based on player inputs in the game's physics.
Section 5. The Python Game Loop.
You can think of the Python game loop as the beating heart of our digital world. It's this continuous cycle running behind the scenes, repeating dozens of times every single second. It's essentially the engine, and it's doing three crucial things all at once. First, it's listening, checking to see if you pressed a button to jump or climb. Second, it's updating, calculating the new physics, maybe shifting the clouds slightly to the left or pushing those water bubbles up. And third, it's drawing. It literally wipes the screen clean and redraws every single tile, background, and sprite in its brand new position, frame by frame. That's what creates the illusion of a living, breathing world.
So the crucial point here is that creating a game isn't magic, it's architecture. It is all about combining strict, logical, mathematical rules, like grids and collision detection, with those layered graphics, the tiles, and the sprites. And it's all driven relentlessly forward by that continuous heartbeat of the game loop.
When you look at it this way, the scene is no longer just a pretty picture. It's a blueprint. Behind that vibrant pixel art is this elegant, structured foundation of Python code holding everything perfectly in place, just waiting for a player to jump in and interact with it.
You've got the foundational pieces now. You understand the grid, the tiles, the sprites, and the loop. The blank canvas is sitting right there waiting for you. So, the only question left is, what digital world will you architect next?